Common things science still can't explain. Fingerprints. That's right. The first entry on this list is something that we all have access to at our fingertips. And that's because it literally is our fingertips. Or more specifically, our fingerprints. I think we all know that everybody has
fingerprints. And beyond that, we all have unique fingerprints. And we also know that the fingerprints your cousin leaves on the glass in every device is really annoying. But beyond the existence and uniqueness of fingerprints, what is there not to know? And the answer is, well, the purpose of all fingerprints to begin with. Interestingly, we actually know a lot more about the origin of fingerprints rather than the purpose of fingerprints. Obviously, in modern times, the fingerprint is an extremely useful tool, most commonly used in forensic your iPhone 6. And while those are definitely interesting use cases for our fingertips, the human body didn't spend hundreds of thousands of years just to develop fingerprints for biometric data purposes. And like the title of this video suggests, the true purpose of fingerprints is still relatively defining features developed on your entire body, obviously after your arms and hands. And these unique designs are carved into your fingertips through the pressure of amniotic fluid in your mother's womb. The pressure of this fluid, coupled with the growth rate of your fingers and other unique factors, are what cause the consistently unique design of your fingerprint, which is really interesting. Your fingerprint isn't genetic whatsoever, and identical twins do not share the same fingerprint. And that same fingerprint you develop early on in your mother's womb, you will keep and are intended to allow you to grip, hold, and throw things easier. And this theory makes sense and is definitely valid. And there is even evidence to support this claim. And the other primary theory for why we have fingerprints is actually for tactile reasons. This theory states that we have fingerprints to help us sense vibrations and to feel textures more fully and effectively, enhancing our sense of touch. And once again, there is evidence to support T. Valid and seem extremely logical, and both share evidence that can back up their claims. There's not yet any concrete evidence proving a specific purpose for your fingerprint, Alzheimer's. If you're watching this video, it's likely that you don't have Alzheimer's. But if you do have Alzheimer's, then it's likely you've seen this video before and just don't remember it. Regardless, Alzheimer's is unfortunately more common than you think, and most people watching this video have likely XP. Truly upsetting. And that is coming from a bystander's perspective. I can only imagine the experience of somebody dealing with the trauma firsthand. But how common Alzheimer's is and how much awareness is being brought to it these days, there are still so many things that are just completely unknown when it comes to Alzheimer's. I think it's important to note first and foremost that Alzheimer's and dementia are not the same thing. And while they are related, they're not interchangeable. Human progression. While cognitive decline is normal as you age, the rapid and detrimental decline that happens with Alzheimer's is nowhere near normal. And for that reason, it's not called old-timers. It's called Alzheimer's. And I'm not even making this up. When I was a kid, I swear to God, I thought it was called Alzheimer's because old people got it. And I'm just really hoping I'm not the only one who thought that. But tossing my own personal cognitive decline to the side, what is they? Common theory is that a combination of age-related brain changes, genetic factors, and environmental and lifestyle influences play a role in the development of Alzheimer's. Although the exact biological root cause of the disease is still unknown. Basically meaning that there's a lot of ways you could potentially get Alzheimer's, like smoking all your life or working shift work and having a bad circadian rhythm, or potentially being genetically predisposed. And while all of these may be that being said, as of now, there are still two primary biomarkers that are believed to be tied to Alzheimer's. The first is amyloid beta plaques. And what amyloid beta plaques are actually buildup of amyloid beta, which is a part of amyloid precursor protein. What does amyloid precursor protein do in the brain, you might ask? Science doesn't know that either, but it's believed, but not proven to have something to do with brain development. Regardless, patients with Alzheimer's will in the brain, causing it to clump together and create plaques, causing the eventual rapid decline in cognition. And the reason for this is because these amyloid plaques are actually toxic to the brain and cause cell death within your brain. Which is why typically in Alzheimer's patients, You will see brains with massive holes in them, which honestly just adds a whole new layer of disturbing to this disease. But even the role of these amyloid plaques are debated because recently there have, like seriously, just imagine being able to be anywhere, and being able to then navigate to a specific location, usually across an entire continent, just because migration is a necessary survival mechanism for countless species of animals. And it's actually common reasons for migration are either to feed, breed, or to escape harsh climates like cold winters or hot summers. And that is simple, and a physical roadmap, and they would still get lost trying to go to a specific location. But if you just tell a butterfly that they've got to fly 2,000 miles to get laid, they're already gone before you could even tell them what direction to go. And it's so amazing, in fact, that we still where to migrate, or more specifically how to get to their point of migration. Birds, whales, sea turtles, and even insects are all examples of animals that migrate. And for most of them, the places they go to migrate are rather specific. Although where they may be living in their off-season 2025, humans have GPS, Google Maps, and now researchers to believe that animals have something that we don't. And recent studies have shown that this could potentially be true. And one example that research has recently shown was that some species of birds, specifically pigeons, were able to sense the Earth's
Only imagine
magnetic
two
field. Scientists just sitting a pigeon down in the lab looking at him and just asking, I wish I had magnition cause that sounds cool as hell. Regardless, with the discovery of pigeons being able to sense the Earth's literal magnetic field, this one answer has led to many more questions, like how many other animals share this ability, and what other abilities exist in the animal kingdom that we don't even know about yet. And for animals with this ability, how do they even use this knowledge of the magnet? Every time winter comes in Michigan, like your drunken uncle could be anywhere in the northern hemisphere for 7 months out of the year, but somehow, as soon as it just gets a little chilly, he teleports to Florida. But nobody knows how he got there. It's just like that. The placebo effect. The placebo effect is a staple in modern medicine testing because of how prevalent it's your mind believing something to be true, and your body kind of following suit. And while that's a bit of an oversimplification, the results of the placebo effect are amazing, but also mysterious. The placebo effect is so strong and so common that anytime a new drug is tested to bring to market, they literally have to test the new drug that's being proposed against a placebo to make sure that the drug is actually effective and not just seeming effective. A new drug that helps people with stomach pain. Now, let's say for a study, you find 100 people that have frequent stomach pain. You divide this group into 2 smaller groups, a treatment group and a placebo group. All 50 people in the treatment group receive the actual medication you're testing. And all 50 people in the placebo group receive, well, a sugar pill, a placebo, a drug that does nothing. It's not even a drug.